Let's look at the next set of problems. Suppose J is between H and K. Use the segment addition postulate to solve for X, then find the length of each segment. So let's just draw a picture first. So J is between H and K. So I'm going to have H and I'm going to have K. I'm going to draw my line. So there's my line segment. And J is between. So I'm just going to put it over here. I never put it in the center because it's not always equal. It's only equal if the problem tells me it's equal. Okay, so that's what my segment looks like. So let's go down and let's look at number 12. So number 12 is telling me that the distance between H and J is 2x plus 4. That's this distance. And the distance between J and K is 3x plus 3. That's the other distance. Okay. And so it also tells me that the entire distance from K to H, or H to K, that this entire distance is 22. So it makes sense that this distance plus this distance equals the entire distance. So that would mean 2x plus 4 plus 3x plus 3 equals 22. Right? This is my yellow. This is my red. And together it equals the entire line, which is 22. So now we have to add like terms. Well, 2x and 3x are like terms. So that's 5x. 4 and 3 are both just numbers. So I can add them. That's 7. And that equals 22. Now I have to solve for x. So I have to get rid of what's being added to x first. So I'm going to subtract 7 from both sides. Both sides of the equals. So that becomes a 0. So I'm left with 5x on this side. And I'm left with 15 on this side. So since 5 is being multiplied to x, I have to unmultiply by dividing. So then that means I'm going to have x equal to 3. So that's my answer for number 12. So I just want to point out to you that notice how I first drew my line, got a picture, and then I took the time to figure out what each segment was, and I color-coded it to help me as well. So that was going to help me get the entire answer on that.